Joey.
Hi, Joey.
There you
Joey's
go.
David. You know what I mean?
It's 101.
Okay, yes, it is more. Okay, if-then statements. Here we go. Okay. In geometry, we have what are called conditional statements, also known as if-then statements, okay? The part that comes after the word if is called the hypothesis. That word should sound familiar. Sometimes you talk about a hypothesis in like a science class.
Oh, yeah.
Right? You have a hypothesis. So if this happens, then...
Wait, what is it, educated guess or what?
Mm-hmm. Then is the conclusion. So we have like a hypothesis and our conclusion. So here's an example. If the team wins the semifinal, so the team wins the semifinal, that's our hypothesis. So if this happens, what's our conclusion? The team will play in the championship. Okay? All right, so here's another example. So our first example, if I pass the driving test, then I will get my driver's license.
That's pretty
Okay.
obvious.
Wait, so what? Oh, so we just have to.
Basically,
But it's the same.
I already passed it.
So we write.
Okay.
So the
I thought that says if I have.
Okay, raise. So the hypothesis don't include the word if. So you're just going to have I pass the driving test. So everything that comes after the word if up until you get to the comma, that's the hypothesis. Okay, so I passed the driving test. That is my hypothesis. The conclusion is I will get my driver's license.
And is it all like that? Past the if and stopping at the comma, or will it?
Yeah, it'd stop at the comma, and then you're gonna write the words that come after then, and up until you get to the period. So we don't include the punctuation marks. So you don't need to put the period after the conclusion. You don't have to put the comma after driving test. Okay? All right. Now, not always do we have conditional statements in if-then form. So, meaning they're sometimes not, you don't even see the word if, you don't see the word then, but it's still considered a conditional statement. So we want to take this example. So it says, every game on my computer is fun to play. We want to rewrite it so that there is if this, then this. Yes. Okay, Vinny?
If I play a game on my computer, then I'll have fun.
All right. So if what? Yeah, what do we have? We have games on my computer. So Minnie said, if I play a game on my computer.
Can you also say like if we?
I will not happen. I will start raging.
So there's slightly different wording that we can use. So you could say, if there is a game on my computer, then it is fun to play. Yeah.
But if I play a game on my computer, it will be fun.
Yeah, I think
Or
something, Minnie
that
said
like
something that Minnie
I
said.
understood.
So then
Pretty good
it
song, or no?
will be.
I thought this was math class, not English.
Okay, but again, geometry has a logic piece to it. So it's something that we call deductive reasoning.
Is that for coding?
So there's a strong correlation between mathematics, geometry especially, and coding. Okay, it's because we have to follow logical steps. We haven't really gotten that far into it in this class yet, but that is why we have to look at these conditional statements. Yes, Aiden.
The first one would like, if every game on my computer is fun, then I want to play. Is that good or?
Well, what's the conclusion though? That it's fun to play. Right?
I have a different question.
Yeah.
Okay. For these, can I just write like addition property?
Mhm.
Just make it short.
Okay. All right. I will buy the CD if it costs less than $15. Boy, that's dated. Who buys CDs anymore? Yeah, Avery.
I got you.
Hold on, Avery.
If the CD costs less than $50, then I will buy it.
Good.
The CD costs less than $15. I will take money
So-
out of my wallet and buy it.
Oh, I see.
Then I will buy it. Oh, you know what we forgot to put in? One thing I forgot to put in the directions, we're going to underline the hypothesis and we're going to circle the conclusion. So on the last one, I'm going to underline, I play a game on my computer. It will be fun is the conclusion. So then if a CD costs less than $15, so a CD costs less than $15, that's my hypothesis. My conclusion is I will buy it. Okay, so I forgot to put that. Okay, David.
If the shape has 5 sides, it's a pentagon.
Okay. A shape has 5 sides if it is a pentagon.
I never said that.
Okay,
Then it is a pentagon.
but do you see where the word if is?
if the shape has 5 sides, it might be a pentagon.
How about this? What's the hypothesis though? What are they saying? If it is what?
A pentagon.
So that's actually what we're going to rate first.
If
It
it
is
is,
a pentagon.
So if
man, this is mad weird.
a shape is a pentagon, then it has 5 sides.
You have to write all these or no?
Yeah, there's not too much of this on the homework. So on the worksheet tonight.
So how is
Uh,
this get me to my goal? How is it supposed to get me to my goal?
So
Are we doing our answer?
I'm not going to go into detail, but again, we talked about deductive reasoning, which is what I have listed next. We use deductive reasoning in geometry, okay? We don't use what's called inductive reasoning that you would use in a science class. Like science class, you do a lab, you do trial and error. With math, we use actual rules, okay? And we have to make sure that the rules follow in the order that we state them. So for example, does it make sense if I switch the order?
Like if is your
If I get my driver's license, then I will pass the test. No, don't you have to pass the test and then you get your license?
If I got my driver's license, I pass the test.
Right. So you have to think about the
But
order
I
that we
did pass
put
the test,
things.
so I don't have to say that. All the other kids here didn't, so I'm good.
Okay, awesome.
Bro, I didn't like
Mine did.
Alright, 3 kids in here.
Okay, next page.
On my left.
We have some properties of equality and properties of congruence. Okay, so some of these you should already know because they're things that we did back in algebra when you were solving equations. Some of these, especially the first ones, might be new. Okay, so I'm going to go through, and you'll see on the next page, and when we get to the homework, you can just use abbreviation, or you don't have to write reflexive property of equality. Think of a reflexive property looking like at your reflection. What do you see? You see the same thing. So
Like 5 equals
5 equals 5. Okay. Again, it seems kind of obvious, but if I said, measure of angle A equals measure of angle A, that's an example of the reflexive property.
That just makes sense.
Yeah, it's like obvious, right? Okay. Next one, symmetric. We've heard of symmetry, right? So what happens with symmetry? It's like if one kind of like think of a heart, if we flipped it around, it would look identical. So look at this is supposed to be an A here.
Oh gosh.
There we go. So it's supposed to say if A equals B, then B equals A. So sometimes if you get -4 equals X, the symmetric property allows me to switch this around and say X is equal to -4. Okay, so just switching things around. We agree with this, right? So when I flip it around, it's got that symmetry. Remember, symmetry is when it's the same on either side.
Oh, yes, I got it.
Okay, transitive property. This is usually a new one. So if A equals B and B equals C, okay, so if A equals B and B equals C, my conclusion is A equals C.
And these are all true, correct?
These are all true.
After then is meant to say X equals 10.
Okay, so we're going to finish. Yes, we're going to fill this in here. So if I told you x equals y and y equals 10, what can my conclusion be based on that transitive property? What can I say?
X equals 10.
X equals 10.
Oh,
Yeah. So that's how the transitive property would work.
I kind of think of it like a train.
Like a
It's
train.
bringing
Yeah.
it on.
So it would be, let's see. If I said, I don't know. Do we have 3 people that are 16 in here?
Yes.
16?
I'm
So
16.
No,
Fred's
you don't have a license.
16
I'm still 16.
and Jonah is 16.
I'm 16.
I'm 16.
And if Aiden is the same age as Fred, then Aiden is also 16. Right? Or like,
Wow.
or if I said, right, like if I said 2 people were 16 and I said, oh,
Why not?
Aiden's the same age as them, then he also has
I got my
to
shit
be
today,
16.
guys.
Should I also
Yeah, I'm definitely a train.
Okay.
I could recognize.
One, we got a couple more here. Some of them, whoopsie. Substitution. Okay. When you have substitution, it's when you replace something with its equivalent. So this is when we replace it.
Wait, but Kayla's 17.
I didn't use Kayla as an example though.
Kayla.
I used Fred, Jonah, and Aiden because they were all
Oh,
16.
Kayla.
No.
Wait, Fred.
Okay.
I'm also 16.
I get it. 3. There were a bunch of people that raised their hand. I just picked 3. Okay. Okay. I could have picked you. Okay. When we use substitution property, okay? Substitution is when we just replace something with its equivalent. Usually we think of this when we simplify something. So for example, 2 parentheses 5 means 2 times 5. What can we replace that with? We can replace that with 10.
Is that like when you reduce fractions?
Yep, when you reduce fractions would also be a good example. Okay, distributive property. Hopefully that sounds familiar. Yeah, so here 2 and then parentheses 3x plus 1. Good.
I said wait. I don't get the substitution.
So substitution is when you replace something with its equivalent. So there's different ways I could use substitution property. So for example, if I said x equals 1, then 2x plus 3 would be what? What would I do with this? Minnie?
You would sub the x for
I would
1.
substitute in, right? So I would replace the x with the 1.
Yeah.
So that would make this equal to 5. So that would be substitution. Another way to think of substitution, so like for example, Fred asked, could I reduce? So let's say if I wrote 8 over 10, can I replace that with something equivalent? Yeah, what would 8 over 10 reduce to?
It's just the like example didn't explain
Yeah.
it well.
There's different
Miss Lisa,
ways.
on
Yeah.
symmetric, which one was the C? Because you actually put C. Which one was that?
Oh, it was here.
It's supposed to be an A.
That's supposed to be an A. Okay, let's name the property. So you have the names listed above.
Symmetric property of equality.
All right, now notice I just highlighted the words. You don't need to worry about writing property of equality. Same thing on the homework. So what do we notice? This has just been switched around. So we can just say symmetric.
Oh, got you.
Okay? You don't have to write property. You could just write symmetric. That's fine. Okay. DE equals DE. It looks like looking into a mirror. It is reflexive property. Again, I'm just going to write reflexive. Okay. So on the homework and then also on the test, I'm going to give you like a word bank. Okay, so you don't have to remember the spelling or anything like that. Okay, C, if angle P is congruent to angle Q, and Q is congruent to angle R.
Is it transitive?
Yeah, so remember Fred made that train Like it looks like a train, so transitive.
Did some of these repeat?
Okay. All right, what do we have for the next one? Substitution.
Measure?
That would be 10.
That'd be 11.
It should be 11.
Oh.
There we go. That's okay. Substitution.
Wait. That's substitution?
Yeah, because we're replacing the value.
Oh, okay.
Okay, next one. This is another. Shh, guys.
Reflexive. Is that reflexive?
Aiden, guys. David,
You.
what do we got?
We got DEA.
Reflexive, when you have the same thing on the same side of the congruent or the equal sign. Okay.
Oh, I put that. Sorry, I thought you were talking about what the problem was.
Oh, no. I just want to know if x equals y and y equals z, then x equals z is
I got it.
transitive.
It's transitive.
Thank you.
Then substitution.
The next no, wrong.
Oh, that's distributive.
Yep, I got you there.
Distributive. Okay, almost done.
Hey guys, who's 100% across? I do.
Not you, dude.
Me right here. Miss Case. Miss Case and me.
I don't know if anybody does.
If you read out his
No,
break
I
the
do.
whole
Miss
class,
Case.
No,
Did you put
just
it?
kindly share it.
Miss Case.
I haven't put them in yet. Oh,
Miss Case, I think I have one.
okay.
I think I have one.
All right. Last part. Okay. These should be even easier because these are just solving equations. Okay, they're just one-step equations. So we're asking ourselves, what can you do to both sides to solve x minus 3 plus, or sorry, x minus 3 equals negative 5. So we have to add 3. So what is our conclusion? X equals negative 2.
Yeah, what you know about verbals? I'm sorry.
All right. Subtraction property of equality. So this is what we would have to do over here. So that x plus 10 equals 21. We would have a minus 10 on both sides. X equals 11. Okay. Again, we're just going to look at one-step equations and we're going to figure out which one of these. Okay, next one is going to be multiplication. So
X equals negative 6.
yeah, what do I have to do to isolate
So you
the variable?
multiply 2 on both sides.
Multiply by 2. So x equals negative 6.
Divide by 3.
Good. And this one, if I have 3x equals 21, I have to divide both sides by 3. Okay. Okay. So now I want to figure out how am I getting from the hypothesis to the conclusion. So what has changed from if measure of angle A equals measure of angle C to measure of angle A plus the measure of angle B equals measure of angle C plus measure of angle B? What have I done? I've done addition. Notice I added measure of angle B to both sides, so that is addition.
Two times. You got it.
So when we add, it should be adding to both sides. Okay, to get from the next one,
Multiplication.
what do I do from here to here? I multiplied, right? I multiplied both sides by 3, so we write multiplication. Okay, next one. If I have x plus 5 equals 7, how do I get my conclusion of x equals 2? Yeah, what did I have to do to both sides? I had to subtract.
No. Wait, oh.
Because remember, you're asking yourself, how do I get from the hypothesis to the conclusion? Right? How do I solve for x? Okay, next one. If AB equals 4 and AC equals AB plus 5, then AC equals 9.
Addition.
No.
Could it be like
Because you add 4 and 5 together, and that makes 9.
Okay, I'm going to draw something.
Is that what division?
maybe subtract?
What am I doing? Kind of. So when I combine something, I'm replacing it with something equivalent. What is, it's on the previous page. Which one was it when I replaced something with the equivalent? I substituted and then combined. So
Wait, but that's not an option.
they're all combined. Yeah.
Oh, for the one before.
So we can still.
Substitution can still be used here.
Oh, this one is the division.
Okay. Yeah. How do I solve? If I have 3x equals 21, x equals 7, what do I need to do to solve? Divide by 3, so division. Oh, well, yeah. Okay. If I have a fraction, I would multiply by the reciprocal. So I would multiply by 3 over 2. So I would say multiplication. Okay, so in order to get rid of a fraction, you have to multiply by the reciprocal. Okay? All right, it's the last two.
Addition.
Addition, do we agree? Yeah, good. And how about the last one? Oh, that's supposed to be, boy.
Wait, that's subtraction.
Substitute, that's supposed to be 36. Boy, I have a couple typos in here.
Oh, what is that?
So I replace something with its equivalent. So watch, we're going to write in here. Okay, the first step is always given. Okay?
What
Now,
does that mean?
well, I have to be given an equation to start with. Okay?
It's always gonna be 5.
Not always, but like if I look at so I'm gonna basically solve the equation for you. You just have to tell me what's the reason for each step. So what did I do from step 1 to step 2? What did I put on both sides?
Substitution?
No.
Multiply?
Multiply. Here, I'll even abbreviate multiplication with M-U-L-T.
Is the next
Okay,
one,
next one is substitution.
Wait, it's not subtraction.
No.
Wait, why is it substitution?
Because so 2 times 7, did I change the value of anything or did I just replace it with something equivalent?
You're
Oh, you're
replacing
supposed
I
to
just
write that.
replaced it with something. And also
I
notice,
wrote a step.
oh, you didn't need to do it like that. Okay, now how do I get from step 3 to step 4? What do I have to do? Subtraction.
And then division.
And then division.
We have to do the bottom part.
Okay, it takes not even 2 minutes. Okay, so you're going to do your own. These are called algebra proofs. So there's more than one way to do these problems. Any ideas? What would you do first?
Add 2/3 on both sides.
Add 2/3 on both sides. Anybody else? What would you do?
Sounds pretty good.
Wait, why is it Z?
Don't
Add 2/3 Z?
you multiply both sides by 3?
Okay, we could multiply both sides by 3. That would be fine also. So what I want you to understand, and there's more than one way. Let's say you don't like fractions and you want to multiply by 3 to get rid of them. So I'm going to multiply both sides by 3. Again, there's more than one way to do this. If you don't like fractions, then I would do this next step. Okay, so I'm going to multiply. This will be 15 minus 2z equals 3. But I need a reason for that. What did I do in that last step?
You substitute.
You could do substitution, or did anybody think distributive property? Remember I distributed? So I'll just put substitution for now. Okay. Now remember, what am I trying to get? I'm trying to get z equals 6 at the end. So it's kind of like I know the answer.
Would you subtract 15 on both sides? The first one
Yeah, I would subtract 15.
So negative 2z equals negative 12.
Okay, so this would be subtraction.
And then
Oh my god. Miss Mason.
Yeah.
Miss Mason. I think I'm about to die of hunger.
This reflects it.
Wait, why did I not